Hey guys, it's Mr. Kilburn, and sometimes, life just kind of throws you curveballs. So my daughter's fever is back up, so she's at the doctor's right now, which means I'm not going to be here tomorrow. I just got done with the meeting. I'm still at school, obviously. It's 3:42. So what I'm going to do is this. I'm going to make a video, but I'm going to make the video using the notes that we were going to use tomorrow anyway and see how this goes. So you're just going to kind of follow along and do what I do and fill in the blanks or do the problems or whatever the case may be, and then we'll figure out what's going to go on after that. All right. So first things first. So you're looking at this page and it says Pythagorean theorem. So I'm going to read this and you follow along. It says in the box below, draw a right triangle using a ruler. So the rulers are up there by the desktop, so somebody can grab those please and hand them out. It can be as small or as large as you want. Next, measure the length of each side to the nearest millimeter. Each square of the measurements of the sides, square each of the measurements of the sides and enter them in the blanks below. Lastly, create an equation that demonstrates the relationship between these three sides. Okay, draw a right triangle in this box and label the three sides A, B, and C. So I'm going to cheat a little bit and use my little widget machine here. Okay, but suppose you make a right triangle and it is something like that. Let me see if I can. There you go. You make a right triangle like so. Whatever, right? Okay, so you've got your right triangle. Then you need to measure the sides of these triangles to the nearest millimeter. Okay? Now I want to do this. No. There we go. So I need to measure this to the nearest millimeter. Okay, so I'm going to say that that is 13. Yeah, call that 13. Okay, so this side is 13. Okay, and then I'm going to measure this side here. I'll call that 5.5, looks like. Yeah, 5.5. 5.5. Why does that keep going away, you stupid thing? Okay, I'll show you. This was 13, and this was 5.5. Okay, so now I need to measure this doohickey down here. And I'm going to call that 12. Yeah. 11.9. So be as close as you can, okay? No, 11.9. Okay, now you need to square each of these measurements. No, I want you to do that. No, you go down. No, no. Oh, you stupid thing. Okay, so I need to square each of these. So 13 squared is 169, and 5.5 squared is, this is just for me, right? You have made your own triangle. Okay, so don't make it just like that. Just make sure it's a right triangle, and use your ruler so it's a good crisp. Okay, 30.25. And the other one here is 11.9 squared. It's 141.61. Okay. So then it says, write the equation that you think explains the relationship between the measurements you just calculated. Okay. Well, go ahead and pause the video for a second and see if you can come up with a way to take these three numbers and just make a basic equation that explains the relationship between these three numbers. Okay, so hopefully you spent some time with that and actually did pause it, Silas. So, I don't know, it's not too awful deep actually. If you look at these three numbers, you might notice, wait a minute, it's pretty not exact, but it's close. okay, it looks like this number plus this number equals this number. Now, it's not exact because we're measuring and you make some minor errors, whatever. But it's actually true. It actually ends up being what happens, okay? So, but I'm going to move this over to here. Okay, and I'm going to move this over to here. Okay, and here's why. Because this is the nuts and bolts of the Pythagorean theorem. Okay, so the Pythagorean theorem states this, that the area of the square off this leg plus the area of the square off this leg, I realize it's not a square, I ran out of room, but you get the idea, plus the area of the square off this leg, okay, this area, a squared, plus this area, b squared, is equal to this area, c squared. Okay, and that is the Pythagorean theorem. A squared plus b squared equals c squared. Okay, I'm going to walk through another physical model with you, but that's it in a nutshell. Did I say nutshell twice? I think I did. Anyway. Okay, so let's back up for a second here. So I think the next page in your notes looks like this. Okay, so this is, I know it doesn't quite look like him, but remember this is, that's Mr. Reed when he was a young man. Okay, back in the, around, I think the year was about 750 AD. Okay, so back then for his high school, they didn't have pictures, they used busts. Okay, so you can notice that the beard's the same, but he does have hair, unlike now. Now he's bald as a cue ball, but he still has a beard. Okay, so that's kind of cool. Anyway, so when we're working with Pythagorean theorem, we're going to work with a square root a lot. Okay, so real quick, some perfect squares: 1, 4, 9, 16, and so on. Because when I take the square root of these numbers, I get integers for answers. Okay, non-perfect squares are anything that's not a perfect square. Square root of 2, square root of 7, square root of 11, etc. Okay. So some basic some vocab for you. So it says today you'll be introduced to maybe the most famous equation involved math, Pythagorean theorem. When you see, I don't know, memes or cartoons or movies or whatever, and they want to just show some random math stuff, a lot of times they'll have the Pythagorean theorem. A squared plus b squared equals c squared in there somewhere, or E equals mc squared, one of the two. Only Einstein's theory of relativity, E equals mc squared, may be more famous. Okay, so vocab, a right triangle. You guys know what a right triangle is. It's a triangle with a right angle in it. The legs. So the legs are the two sides that make up the right angle. All right, so in this case, A and B are the legs of that triangle because they make up that right angle. And the hypotenuse is the longest side of a right triangle, right here. Okay, it's always opposite the right angle. Go away. Okay, so the right angle always points to the hypotenuse. So there's never any question where the hypotenuse is. It's always the longest side, and it's always opposite the right angle. Okay, so there's some basic vocab for you. Okay. Okay, so I just mentioned that. I'm going to skip that. Okay, so here you have some writing to do here. But we're gonna prove something to you. Okay, so we're gonna prove the Pythagorean theorem using an area dissection model. So a dissection model, if you've ever dissected anything in science class, or if you're bored and you find like a dead squirrel or woodchuck or whatever, you got a knife on you and you want to take them apart, you dissect them, right? So we're not going to do anything like that in math class, obviously, but you can use what's called a dissection model when you're breaking apart like polygons and whatnot. Okay, so it says let's create two equal squares that each have a side length of a plus b. All right, so we need to figure out, well, how can I make a square so that each side length is a plus b? So if I was there in class, we would, I'd call some of you up and see if you can generate a square so that each side Oh, I didn't mean that to come up yet, sorry. Each side has a length of A plus B. Okay, so let's see here. No, you go here, you go here. Rotate this. Yep. Here. And this is going to get rotated here. Okay, so if you notice that, right off a little bit. So this side is A plus B. This side is just, hang on, I need to rotate this. Oh crap. I don't want to do that. Group. Okay, this side is, no, stop doing that. Okay, over here. Okay, there's an A missing here somewhere. Where'd it go? There it is. Voila. Okay, so here's a square, and each side length is A plus B. A plus B, A plus B, and A plus B. There should be a B here, it's missing. Okay, so this is a square, each side length is A plus B. Okay, now over here, after a little bit of work, a lot of times students actually do a pretty good job with this too. They're like, wait a minute, I can do this. Oh, you stupid thing. And then this, and then this, and then this. No. Good. Voila. Pretty close. And then inside here is this square. So once again, each side length of the square is A plus B, A plus B, this A plus this B, this A plus this B. Okay, you may say, well, okay, big whoop-de-doo-doo. Well, we're going to prove the Pythagorean theorem now. All right? So look at the first square over here. Okay, what's it made up of? What's it made up of? Well, it's made up of this little purple square. What's the area of that purple square? A squared. Okay, and I'm going to change it to this in case it starts to lag. Okay, A squared. And then it's made up of this, these two triangles here. Okay, the area of a triangle is 1/2 A times B. So it's made up of a 1/2 A times B, another 1/2 A times B, because there's two of those triangles. Okay, and look at these triangles here. Okay, all these triangles are the same size. I just cloned these when I first made this. So there's actually 4 triangles, each one with an area of 1/2 AB. Okay, and it's also got this big orange square. So it's got all those. So it's a lot of stuff. Okay, now what's square 2 made up of? Well, square 2 is made up of the same 4 squares. Okay, so I'm going to write it below here a little bit. So 1/2 AB plus 1/2 AB plus 1/2 AB plus 1/2 AB plus that big green square, which has an area of C squared. Now, these two squares have the exact same area. Okay, because each side is made up of A plus B, so they have the exact same area. So keep that in mind. Now, so if they have the exact same area, these two expressions are also equal. Okay, so take a second, make sure you copy down what I have here. Pause the video if you have to. But get all that stuff written down, and I'll simplify it in a second so it's not so much writing. Okay, so look at the first square here. Okay, are all these like terms to ABs? Okay, yes they are. So what's 1/2 AB? What's a half plus a half plus a half plus a half? A half a pizza plus half a pizza plus half a pizza plus half a pizza would give you 2 pizzas. So this side is really A squared plus 2AB plus B squared. and it's equal to what's over here. In this case, adding up all those half ABs, I get 2AB plus that C squared. Okay. Now, do you see something on both sides? That's an A right there. Do you see something on both sides that can be subtracted? The exact same term on both sides? I knew you did. I can subtract 2AB to both sides. Okay. Okay. Go away. So those cancel, and look what you're left with. A squared. Come on. Of course now you're going to come up. A squared plus B squared. Okay, that's really messy, but there we go. It's coming up. Stupid delay. Okay, A squared plus B squared equals C squared. So we just proved it. Okay. All right. Now, yeah, it's kind of a nerdy thing to do. I get it, but it is what it is. Okay. All right. Next. So let's do some examples here. Now, when you're solving these, keep in mind again, the hypotenuse is always opposite the right angle. And when you're doing Pythagorean theorem problems, I always want to see you writing down the theorem first. So A squared plus B squared. Okay, you are just getting annoying. A squared plus B squared equals C squared. No, go away. Sorry, guys. Got technical difficulty. Okay, try again. Okay. A squared plus B squared equals C squared. Okay, so I'm just going to do a couple of these just to keep this video somewhat not too long. I know it's kind of long already, but it's okay. All right, so for A and B, you always plug in the legs. It doesn't matter what you plug in for A, what you plug in for B, as long as you plug in these two legs. So I'm just going to plug in 3 for A and 6 for B. And I need to figure out what C is, what the hypotenuse is. So 3 squared is 9, 6 squared is 36. Again, if I go too fast at any point, you pause and back it up. 9 plus 36 is 45. And like we practiced today, I don't want the square of a number. I want just the variable. So I need to take the square root of both sides. Okay. And in this case, the square root of 45 to the nearest tenth, 6.7. Okay. So the Pythagorean theorem is really handy because if you have two sides of a right triangle, using the Pythagorean theorem, you can figure out the length of that third side, whether it's the hypotenuse or whether it's a leg. So there's an example of finding the hypotenuse, and let's find one where we're trying to figure out the leg. That's another hypotenuse. Okay, here. So look at example 3. So here's a leg, here's a hypotenuse. Don't worry about the fact that it's different letters. This usually gets referred to as A, B, and C. Okay, so we're going to start by writing down the Pythagorean theorem. A squared plus B squared equals C squared. Okay, so they tell me that L is 65 and J is 33. All right, so look, L is 65, but L is the hypotenuse, so that always gets plugged in for C. The hypotenuse is always, always, always C. Okay, so what you plug in for J and K, well, in this case, I tell you what J is. It's 33. All right, but it doesn't matter what you plug it in as far as A and B is concerned. Either one doesn't matter. Okay, so 33 squared is 1,089. Um, 65 squared is, oh, come on, 4,225. Okay, subtract 1,089 to both sides. And B squared equals 3136. 1, Okay, but I don't want b squared, I want just b, so take the square root to both sides, and the square root of 3136 is 56. Well, I'm going to say c equals 56, or for the letters they used, L. Come on. Either way, this thing right here. Okay, so there's an example of having two legs and figuring out the hypotenuse. The one we just did is an example of a leg and a hypotenuse and figuring out the other leg. So again, just real short to summarize quickly here. The Pythagorean theorem says that if you have two sides of a right triangle, you can figure out the third side by using the Pythagorean theorem. A squared plus b squared equals c squared. Alright guys, so I'll just have a few practice problems for you to do after you watch this video. Listen, if you haven't hammered the subscribe button, I don't know what's wrong with you. If you haven't enabled push notifications, you're just weird. Alright, and if you haven't liked it, you got issues. Serious issues, okay? You've got issues, and I got tissues. Alright guys, I'll see you tomorrow. Have a great day. Keep it real. I'm out.